Okay, so 4.5, the substitution rule. The substitution rule says that if u equals g of x and u is differentiable, then the integral of f of g of x g prime of x dx is equal to the integral f of u du. Which basically means you can substitute u in for g of x, which is why it's called the substitution rule. Okay, so let's look at actually putting u to use. So if I look at example 1, I'm given the integral of 2x times the square root of 1 plus x squared dx. And because this is a complicated equation, we normally would not be able to differentiate it or integrate it based on how it is now. So that's why we use u to try to simplify it. So I'm going to let u equal 1 plus x squared. And so then du, my derivative of 1 plus x squared. What is the derivative of 1 plus x squared? Derivative. What's the derivative of 1?
0.
0. Okay, and what's the derivative of x squared? 2x, right? So the derivative of 1 plus x squared is just 2x. If I roll down that 2 and then reduce my exponent by 1, I end up with 2x. So that tells me that I can replace this 2x with du, and I can replace this 1 plus x squared with u, so I end up with the square root of u du. Okay, well the square root of u is just u to what exponent?
2.
1/2. Square root is 1/2, right? So that's like u to the 1/2. And we know that we can integrate anything to the 1, or anything to any exponent by adding 1 and then dividing by n plus 1. So 1/2 plus 1 is 1 1/2, so 3/2. And 1 plus 1/2 is 3/2. So this integrates to u to the 3/2 divided by 3/2. If I simplify that, then this 3/2 becomes 2/3 u to the 3/2, because dividing by 3/2 is the same thing as multiplying by 2/3. And then finally, our last step is to replace u with what it equals. So u in this case was 1 plus x squared. So this would integrate to 2/3 times 1 plus x squared to the 3/2. So using u helps us take very complicated equations and integrate them in a way that makes sense. Just leave it like that. Yep. Okay, so let's look then at example 2. I'm given the integral x cubed cosine of x to the 4th plus 2 dx. What do you guys think I should let u equal? If you had to guess, what would u be?
The x to the 4th plus 2.
Very good, and the x to the 4th plus 2. So if I differentiate u, what is the derivative of u? Four x cubed, very good. So I want to replace in here the things that I have. So I can replace this with u. and 4x cubed. I have an x cubed already. I don't have the 4. So if I wanted to add the 4, the opposite of adding the 4 would be adding 1/4. So this would be like 1/4 cosine of u du. Adding the 1/4 would undo what I added when I added the 4, leaving my equation the same. Because if I add a 4 inside, then I want to add a 1/4 outside so that they cancel. So I'm not really changing my equation, I'm just rewriting it. Does that make sense? Okay. So then what is the integral of cosine? Based on your integration rules that we went over on Friday, that whole table, what did we say that the integral of cosine is?
Sine x plus c.
Okay. So the integral of cosine is sine, so this integrates to 1/4 sine of u plus c. Yep. So then if I replace my u with what it originally was, u was originally x to the 4th plus 2, then this integrates to 1/4 sine of x to the 4th plus 2 plus some unknown constant. If I look at example 3, I'm given the integral of the square root of 2x plus 1 dx. What should I let u equal? 2x plus 1. So then what's the derivative of 2x plus 1?
3.
What's the derivative of 2x?
2.
2, and what's the derivative of 1?
0.
So this is just like 2, right? The 1 just goes away, so the derivative of 2x is 2. Okay, I have my 2x plus 1. I don't have my 2, so I need to add my 2. The opposite then of adding a 2 is putting a 1/2 out. So then I can replace the 2 in the dx with the u, and I can replace this with u. So I get 1/2 the integral of the square root of u du. Well, the square root of u is the same thing as u to the 1/2. So if I integrate u to the 1/2, what am I going to get? 1/2 plus 1 is?
3/2.
Okay. Dividing by 3/2 is the same thing as multiplying by 2/3. And so if I simplify these, the 2's cancel, and I end up with 1/3 u to the 3/2. And what did I say that u equals? X plus 1. So then I back substitute what u equals in for u, and this simplifies to 1/3 times 2x plus 1 to the 3/2. How do we feel about these? Good? Bad? Do you want to do some more? Okay. Alright, so if I look at example 4, I'm given x divided by the square root of 1 minus 4x squared dx. Kira, what do you think I should let u equal? Okay, so 1 minus 4x squared. So then what would my derivative equal? Negative 8x. Good. And I already have my x, but I don't have my negative 8. So if I add my -8 to the inside, then I'm going to add -1/8 to the outside. So then I can replace -8 over x with du, cancel out my dx, and replace 1 minus 4x squared with u. So I end up with the integral of 1 over the square root of u du. Okay, and we've said that the square root of u is u to the 1/2. So if I move that to the top, so it's something I can integrate, this changes to u to the -1/2. So I get -1 over 8 integral u to the -1/2 du. So let's integrate that. -1/2 plus 1 is 1/2. So this becomes u to the 1/2 divided by 1/2, and I still have my -1/8 out front. Dividing by 1/2 is the same thing as multiplying by 2 over 1. And so if I simplify those, I end up with -1/4 u to the 1/2. So then, Kira, what do I get if I back substitute u back in?
1 minus
Again, -1/4 times 1 minus 4x squared to the 1/2 exponent. All right, let's do one more indefinite integral, and then we'll do a definite integral. Okay, so if I give you the integral of cosine of 5x dx. Mikey, what should I let u equal? I can't let it equal the whole equation. I have to let it equal part of the equation, 5x. Okay, so if I let u equal 5x, what's my derivative of 5x then? 5, yep. So then if I cancel this out, I have the 5x, I don't have the 5, so I have to add the 5. And then, so then on the outside, I have to add the 1/5 so that it doesn't change my equation. So I replace the 5 with du, and I replace the 5x with u. So I end up with the integral of cosine of u du. And the 1/5 just stays out front. Okay, so what's the integral of cosine of u du? Sine, right? The integral of cosine is sine. So this becomes 1/5 sine of u. So if I replace u with back substitute u, Mikey, what am I going to get? If I put this back in for u, what do I end up getting? Okay, so 1/5 sine of 5x, right? Okay. Okay. The other part of using the substitution rule is for when you use it with definite integrals, meaning integrals that give you an upper and lower limit. So if you're integrating a definite integral using the substitution rule, the equation part stays the same, but you have to change your limits based on whatever you pick to be your g of x, whatever you pick to be your u. So you have to plug in your lower limit into g, and you have to plug in your upper limit into g in order to get your new limits. So if I look at example 6, I'm given the integral 0 to 4 of the square root of 2x plus 1 dx. Okay, so what should I let u equal? 2x plus 1. So what's my derivative of u? 2. Okay, so if I'm going to add a 2 on the inside, I need to add a 1/2 on the outside. That's the first part. I also need to find my new limit. So if I want to find my lower limit, remember that u is also equal to g of x. So if I want to find g of 0 then is equal to 2 times 0 plus 1. So what is 2 times 0 plus 1? 1. Okay, so I know that my new lower limit is 1. If I want to find my new upper limit, I'm going to plug in 4 to my u equation. So then 2 times 4 plus 1. And 2 times 4 plus 1 is 9. My new upper limit is 9. So I'm left with 1/2 square root of u du from 1 to 9. Okay, so let's integrate the square root of u. This is like u to the 1/2. And so if I integrate that, what am I going to get? U to the 3/2 divided by 3/2. And dividing by 3/2, remember, is the same thing as multiplying by 2/3. So when I simplify, this simplifies to 1/3 u to the 3/2. And I'm going to evaluate that from 9 to 1. So if I start by plugging in 9, I end up with 1/3 9 to the 3/2 minus 1/3 1 to the 3/2. Okay, so what's 9 to the 3/2? 27, and then times 1/3 would give me 27/3. And 1 to the 3/2 is, what's 1 to any exponent? 1. So 1 to the 3/2 stays 1, so then times 1/3 gives me 1/3. And 27/3 minus 1/3 is 26/3. That's it. Okay, so substitution rule works the same for indefinite integrals as it does for definite, except you have to change your limits. So your assignment is page 335, 1 through 10, and 35 through 40.